morning to one and all who are presented here. This is Sarthak Pandey from class 11th, and today I am here to present you a presentation and discussion on the topic the pseudo force. So basically, before beginning the pseudo force, I want to discuss that this topic comes under as a subtopic in the Newton law of motion. And before going into the depth of the topic, I just want to break down what's the actual meaning of this topic. As the name suggests that pseudo force, so basically the word pseudo means false. Hence, we can conclude here that the pseudo force means a type of a false force. So, for understanding it in a better way, that what is the force and why this concept developed, firstly we have to take two cases. Let's take them and let's observe what is currently happening in these cases. So there are two cases, and we are assuming that these two boxes are acting as a lift. It is the lift 1 and it is also the same lift, therefore it is denoting it both as the lift 1 and lift 1. So I am putting, suppose a ball is there and I am putting a ball here and the same ball I am putting here. So this is the two cases that I put the two balls in these places. Now I want to say to you that you have to observe what is happening in this. So we can conclude in the Newton law of motion, we basically discussed that what is happening to these blocks and what is happening to the balls. Basically, which force is going to apply in these boxes. So we can observe that as this ball and this lift is in contact with each other, therefore the ball is applying a force in the downward direction towards the surface of this lift that is equal to its weight, that is equal to mg, because I am supposing its weight to be mg. And this is also m because of its mass, therefore the force in weight in this direction is also mg for this. And I am also saying that these lifts are going upward with an acceleration of a. Okay, now the main concept starts from here, that we know that this block is going downward, applying the force, and the lift is going upward. The same case here. Now comes the difference that I said. Also, there will be a normal reaction force that is opposing this mv, because we can understand that this whole thing is in equilibrium, means that the block is currently at rest, and means it at its stable condition, means that an equal force is also there, that is Newton's third law, that an equal force of same nature is also present here, which is opposing this mv in upward direction to let this block be stable. Therefore, the force I am denoting it as here as n. And same also this as well. Now I am saying that we have to find the value of this n, the force n we have to find. So before finding the value of n, we can also have to understand that how to find the force n. Now let's take an example of a pulley system. Like suppose we have a pulley and a block of mass like 3 kg and 2 kg are present here, and we have to say that find the acceleration of the blocks. So this is the question presented to us, and it is stating to find the acceleration of this block. So there is a shortcut method to find the acceleration of these blocks, because we can understand that considering this as an ideal pulley, we know that the 3 kg block is going downwards and this is applying a force of 30 Newton, and this block is going upward because the acceleration is downward here and the acceleration is upward here, because the pulley will swung down with 3 kg weight, the bigger force is downward, therefore it will be like 30 Newton downward, and for this also their force will be 20 Newton downward direction, but as it is bigger force and it is a lesser force, the block will come downward with an acceleration of 8. We have to find the value of this 8. So what we can say that the acceleration, the ma is equal to f2 minus f1. Here the f2 is basically the supporting force to the acceleration, and f1 is the opposing force. So we can conclude that because the acceleration is downward, this is the supporting force. Therefore it will be like 30 minus the opposing force, that is 20, and acceleration we can set this m into the division, and that m will be the mass of whole blocks, like this 3 plus 2, that becomes 5. Therefore the acceleration is like 2 meters per second here. So basically I want to say and conclude to you that the acceleration is basically f2 minus f1 upon m. This is the acceleration. Now returning back to our question to find the normal reaction force. So I am stating that suppose a person is standing on the ground. We are letting this person stand on ground and it is observing the normal reaction force. Therefore, for this acceleration, what will be the normal reaction force? He will say that I am observing, like you also can see that if I say like this pen is going upward and upward and upward, so you can see that it is having an acceleration. And if suppose I say this is our block, this is our lift, and this pen is going upward, so you can feel that some acceleration is taking it upward, and the normal reaction force of my hand is also applying on it. Similarly, if I say from the ground, so what is being observed here? That it is observing that this normal, because of the acceleration being upward, this normal becomes the supportive force, that is N. Then it has minus the opposing force, that is Mg, is equals to the acceleration of this whole lift, that is Ma. Therefore, the Newton from here, the normal reaction force from here becomes N plus Mg. Okay. I am getting it like the new normal reaction force from ground perspective, it's N is equal to Ma plus Mg. Now let's come here and we are saying let's suppose a person is standing in this lift. So if the person is standing in lift, what you will observe? Like think about if you are a person standing here, so and the lift is also going upward, so you will not feel any type of acceleration here. The acceleration for you is the observer here, so the acceleration is for you is here is 0. Therefore, what he will say that normal reaction force is equal to Mg. Just so there is a difference in the same scenario after observing that the person, because normal is seen from all the perspective there, but why is the difference occurring here? That is the concept of pseudo force, because in physics the Newton the normal reaction force and like the tension force is similar from all the perspective and from all the references. This conflict is occurring because we have two different types of perspective, and there comes the concept of pseudo force. To normalize both being equal, as on the experiment data, it is observed that this N is equal to Ma plus Mg is the correct normal force. Therefore, to balance this, we add a false force. It is not actually occurring in this case, but we add it to normalize this and this to become N is equal to Mg plus Ma, and this will also become N is equal to Mg plus Ma. So this Ma, that is the mass of the block and the acceleration of the person. The mass of the block and the acceleration of the person, this is the Ma, and this is our pseudo force, just to balance this. So this was all from me, from my side of pseudo force, and thank you for giving me this opportunity.